The YFQ-42A is a prototype aircraft developed as part of a next-generation initiative aimed at redefining how air forces operate in complex, high-threat environments. It belongs to a class of aircraft being developed under the Collaborative Combat Aircraft (CCA) program, which focuses on integrating uncrewed systems into manned-unmanned team structures. These systems are not replacements for traditional piloted aircraft, but rather force multipliers, designed to extend reach, provide flexibility, and take on missions that would be too dangerous, too time-consuming, or too costly for piloted jets alone. As of late August 2025, the YFQ-42A has completed its maiden flight. This event, while not the final proof of readiness, represents a key validation point in the aircraft's development. It confirms that the vehicle is structurally and technically sound enough to conduct sustained flight, which is a critical step before it can enter more complex phases of testing such as operational mission simulation, integration with existing platforms, and evaluation in contested airspace scenarios. The development timeline of the YFQ-42A has been notably accelerated. From the awarding of contracts to first flight, the entire cycle took about 16 months. In traditional defense aviation development programs, such progress would have taken years. This speed suggests a major transformation in how aerospace acquisition is being approached. The traditional model of long development, protracted testing, and phased procurement has been replaced, at least in this case, by a strategy emphasizing modularity, digital engineering, and rapid prototyping. This was possible in part because the YFQ-42A builds on prior experimental platforms, such as the XQ-67A, which helped lay the groundwork for its airframe and internal systems. Unlike legacy drones that were primarily used for surveillance or occasional strike missions, aircraft like the YFQ-42A are being built with the intent to participate directly in complex air operations. These include electronic warfare, suppression of enemy defenses, forward scouting, communication relay, and precision strike, all within high-threat environments where stealth, speed, and responsiveness are essential. The vehicle is expected to function both independently and cooperatively with human pilots, which demands a high level of onboard decision-making capability. This includes automated navigation, target recognition, threat avoidance, and coordination with other platforms, all without constant human oversight. Its modular design is a core feature. Modular systems allow the aircraft to be outfitted with different mission payloads depending on operational requirements. For example, the same basic airframe could carry sensor packages for intelligence gathering, jamming equipment for electronic warfare, or weapon systems for offensive roles. This flexibility reduces the need to manufacture and maintain many specialized aircraft. It also means that upgrades can be integrated faster, allowing the system to evolve as threats change. In terms of logistics and fielding, the YFQ-42A and its counterparts are being designed for ease of deployment and maintenance. Components are intended to be interchangeable, and the aircraft is likely to have a simplified maintenance schedule compared to traditional fighters. This supports the concept of distributed operations, where assets can be dispersed across multiple smaller locations instead of concentrated at large bases, thereby increasing survivability and resilience in the event of conflict. The lower cost and uncrewed nature of the aircraft also allow it to be used in missions that would otherwise be too risky or resource-intensive to justify using manned aircraft. The YFQ-42A is one of two major prototypes under evaluation in the first increment of the CCA program. The competing aircraft has not yet been confirmed to have flown. Both prototypes will undergo testing through 2025 and into 2026, during which time performance, reliability, mission adaptability, integration with other systems, and maintainability will all be assessed. The goal is to decide on a production-ready configuration during fiscal year 2026. At that point, the winning design, or possibly both, could enter limited production and begin operational integration. Initial procurement plans call for between 100 and 150 aircraft under this first increment. However, the long-term vision for the program is significantly more ambitious. Projections suggest the eventual acquisition of over 1,000 units, potentially including multiple airframe types optimized for different mission roles. These aircraft could eventually support a wide range of operations, not only in major conflicts but also in lower-intensity operations and even peacetime missions like border patrol, surveillance, and disaster response, depending on configuration. One of the most challenging aspects of integrating the YFQ-42A and similar platforms into the Air Force structure will be operational concept development. Unlike traditional aircraft, which are flown by highly trained pilots who make real-time decisions, the YFQ-42A must rely heavily on pre-programmed mission parameters, onboard artificial decision systems, and secure, high-bandwidth communications with operators and other platforms. This raises questions about trust, control, and responsibility during complex missions, especially when coordination with manned aircraft is required in dynamic, potentially hostile environments. The communications infrastructure required to support these aircraft is being developed in parallel. Secure, resilient, high-speed networks must be in place to allow the aircraft to receive updates, relay information, and coordinate with other units, whether airborne, ground-based, or maritime. These networks must be resistant to jamming, interception, and cyber attacks. Given the growing complexity of the modern battlefield, especially in environments where access to GPS and satellite-based systems might be denied or degraded, the success of the YFQ-42A depends as much on its digital backbone as on its airframe and engines. The YFQ-42A is part of a broader transformation in military aviation. It reflects an urgent push toward greater adaptability, speed, and survivability in future combat scenarios. The successful completion of its first flight marks a concrete achievement in this process, but it is just the beginning. What lies ahead is a complex series of technical, operational, and doctrinal challenges that will shape how this aircraft, and others like it, are deployed in real-world missions. As testing continues, the results will provide critical insights into how effective uncrewed systems can be when paired with traditional air power in tomorrow's conflicts.